Hello and welcome to another lecture. I'm Professor Slominski, and in this lecture we're going to effectively use pseudocode to construct an algorithm. In this lecture I'm going to explain the main verbs used in pseudocode and how to effectively use pseudocode to construct an algorithm. So let's go ahead and get started. What is pseudocode? It's a notation resembling a simplified programming language used in program design. Why would we use pseudocode? Well, pseudocode allows us to have a simplified language to express the steps of an algorithm. Oftentimes what will happen is in languages like C, C++, Java, we'll get bogged down by all the semantics and language versus the algorithm. So pseudocode strips all the unnecessary syntax away, all the unnecessary structure away, and allows us just to look at the core algorithm. So here are some simple guidelines to follow when writing pseudocode. We're going to write one statement per line. We're going to capitalize initial keywords. We're going to indent for a hierarchy. We're going to end multi-line structures. And we're going to keep statements language independent. This means that no matter what language you decide to implement the pseudocode in, whether that be C, C++, Java, Python, whatever, it won't matter because the pseudocode isn't using a specific language to express itself. It's a general language. The source is at the bottom. You could take a look at that. There's some more resources there. All right, so what are some common verbs to use when writing pseudocode? The keywords that you're going to want to use are things like begin and end to let the function know it started and ended. Input, get, or read to let the reader know that you're getting something from the user. Computer, calculate, add, subtract, initialize. This will be part of what the computing agent does on the given data. Output, print, display to print the answer. If, else, if, end, if for conditional statements. While, end, while for loops and iterative statements. And for, end, for again for iterative statements. All right, so let's look at the problem statement. We want to construct a program that will take two numbers, m and n. If m is greater than n, the program will swap the values of m and n. If m and n are equal, the program will set both values to 0. Be sure to print out the value of each variable before the program terminates. Now notice I didn't tell you any instructions on what to do if m is less than n. If they are, we're just going to print them out in the same order. Okay, so here are the example runs. Whenever you do stuff like LeetCode or TopCoder or stuff like that, they'll always give you a problem statement. They'll give you some example runs, and they'll also give you some constraints. We're not going to do the constraints right now. The constraints would be m and n are going to be integers if I were to give you one. So case 1, m is greater than n. So please enter m, 6. Please enter end, 3. And the output is the swap. So m will be 3, n will be 6. Case 2, m is equal to n. So they're equal. As we said in our problem statement, we make them both to 0. In case 3, m is less than n. We don't do anything. We just print out the values as they were given to us. All right, so let's take a look at the pseudocode. I should have put an end at the bottom, just so you know. In the future, if you're doing this, make sure you put an end to every begin. So begin. We want to get m from the user, get n. You could say prompt or get, whatever verb you want to use. In this particular algorithm, I decided to use get. If m is greater than n, we set temp to n, set n to m, and set m to temp. I'm going to go into a little bit more detail on the swap algorithm in a minute. But just know that this is what happens. If m is greater than n, we swap the values of m and n. So n will take on the value of m, and m will take on the value of n. If m is equal to n, we just set both m and n to 0. Notice there's no need to swap. We're just setting both to 0. And the other one, we don't need to do an if statement for that. We just go ahead and print out m and n as it's given to us. So now we're going to print output. We're going to print out m equals m and print out n equals n. Now this is just some common formalities in pseudocode. You could just write it that way. All right. So that's our algorithm. Now, why did we do these steps here? Set temp to n, set n to m, and set m to temp. Why did we do that? Well, let's take a look. Here's a quick swap algorithm explanation. First step, temp equals n. Okay, so temp is going to equal 3. Okay, you're just going to set it equal to whatever n is. Second step, n is equal to m. So n is now 5. Okay? This is the nm swap. So n is now 5. Uh-oh. We have a problem. Notice we've lost the value of n. N is now 5 and so is m. Right? N and m are both 5. Both variables now have the same value. So what are we going to do? Notice that we saved n and temp at the start, right? We said temp equals n. So temp is holding 3. These two are both these two gray boxes, m and n, are both holding 5. But temp, thank goodness, we remembered to save n in there as 3. So we're just going to simply say m is going to equal temp, which was the old value of n, because we lost n when we did this second step right here. So that's a very traditional swap algorithm. There's another type of swap algorithm where you don't need a third variable, which I'm not going to go over right now. It's trickery. It's something that you potentially use for an interview if the interviewer wants to ask you a tricky question like, can you swap two values without using a third temp? Right, we could go over that another time. But the thing I want you to understand is we use the temp variable to hold the old value of n so we don't lose it. And when we swap them, we maintain our value. So this is like a sub-algorithm in here. Okay? So hopefully you understand why we use pseudocode, how we use pseudocode, and how pseudocode helps us to create algorithms and solve problems. Thank you for watching.